Okay, Bismillah. Assalamualaikum warahmatullahi wabarakatuh. Alhamdulillah, hamdan kathiran tayyiban mubarakan fi kama yuhibbu rabbuna wa yarda. Asyhadu an la ilaha illallah wa asyhadu anna Muhammadan abduhu wa rasuluhu la nabiyya ba'da wa la rasula ba'da. Amma ba'd. Hello everyone. Welcome back to another video in this channel. And for today, I want to give you guys a demonstration or an explanation about my newest project, which is about the weather station project. So in here I'm going to explain first what is a weather station. So in this project, weather station is like where you can detect basically detecting the weather, the temperature and the humidity of your room or your surroundings. So it's basically kind of the same like greenhouse, but greenhouse is only for your house, and for this is for like checking your weathers on your based on your places. Okay, so now we made this project using two platforms: Wokwi for the sensors, connecting the sensors, and also making the code, because this is based on simulation, not actual hardware. And the second software or the second tool that we use is Adafruit. So what is Adafruit? Adafruit is a cloud place for holding your data in the Adafruit, which is the cloud. So all the data that we'll receive from this DHT sensor will be saved in this platform, which is Adafruit. So we use Adafruit here to make the feed or the dashboards. Here is to save the information that we get from this simulation. So after we get the data from the data from the simulation, we insert the data immediately to the dashboard, which will be the data that we save in the I/O. Okay, so now I want to explain the code a little. So here is about the include. So this is just including libraries if you don't understand. So it's just including the stuff that we use for this that is not included in the Arduino code. So it's about the Wi-Fi library, the Adafruit library. So this function is for connecting from the Wi-Fi to the Adafruit website, and also the DHT. And here the const integer is for declaring the pin that we use on the DHT. So here we connect the DHT pin to the 14, right? Okay, I forgot to explain. This is for the VCC, we connect it to 5 volt, and the GND connects to the GND or ground. And here we connect the SDA to the pin, and here we use 14. So here we declare the pin that we use for the DHT is 14 to input the data, which is an integer data because it's only simple numerics. Okay, and here is for initializing the DHT sensor. So it will initialize the DHT sensor to detect the temperatures or the data that they are going to insert to the I/O. And what is this? So here this define Wi-Fi and I/O usernames is for connecting to the Wi-Fi. So because we use Adafruit, we must connect it to the Wi-Fi because it's connected to the cloud. So in order to have the data inserted into the I/O, we must use the Wi-Fi. And because we are using a simulation, we use this Wokwi Wi-Fi. But if you are using it using real hardware, you can use a real Wi-Fi ID and your Wi-Fi password in your home. And here is the I/O username. So this is for connecting it to your account in your Adafruit I/O. So we must make an account. So how to get it is you just click this API key here, and then you can copy it and insert to the code. So without this, we cannot insert the data inside the I/O because we need this to access the I/O and to insert the data to the I/O that we are putting it as the destination. And here is for declaring to connect the Wi-Fi. So here is the I/O username. So this is for connecting to the Wi-Fi. And here is the I/O username. So this is for connecting to the I/O and to insert it. So we need this to access the I/O and to insert the data. with this when we defined it before. Then this is for making the other object for the feed, and this is the feed. So this is the feed for inserting the data, or we send the data to the I/O. So in here I want to show you the feeds. Here is same, yeah. Make sure the name of the feed is the same in the I/O and the code, because if you mistake even one, it will change the data completely, so it will not transfer the data to the I/O. Okay, and here's only for a delay function that I will explain later. And here the voice setup here. So this is the code for connecting to the I/O. So here there is a code about the while. So while it's trying to connect to the Wi-Fi, it will show or print that it's trying to connect to Wi-Fi in below here. And if it's already connected, it will show connected to Wi-Fi, and then the DHT sensor will begin reading data. Then after that, in the void loop code, we run the I/O. So here we have a variable of temperature and humidity, and it equals this, which is, so later the variable will insert the code that is read from the DHT22 sensor. And here this function of the if code is for checking if the DHT sensor is working or if any reads are failing. So if we change like the pin here, because in the code to declare the pin of the DHT is 14, but if we connect it to maybe 32, well, it will print failed to read from DHT sensor. Now we continue to this last part of code, which is this. So here I want to explain. So it will count here if millis minus previous time less than delay time. So this means if so milliseconds is like milliseconds, it will go from 1 2 3 4 5. But if it's minus previous time, as we can see here, the previous time, as I've said before, the previous time, the value is 0. So we continue, because here the previous time the value is 0, so the milliseconds will be decreased by 0. So it means it will continuously count until more than the delay time. So here the delay time is 1000, right? So it would count over until 1000. So it would 1 2 3 4 5, because it's minus 0, it will not change at all. So it would be 1 2 3 4 until 1000. And if it's already more than 1000 milliseconds, then it would save the data that we received from the DHT sensor to the I/O, and also for the temperature and the humidity. After that, it will print how many temperatures and humidity is sent to the I/O. After finishing printing, it says here in the code previous time equals millis. So after the milliseconds is more than the delay time, which is 1000, right? After printing, the previous time will have the same value as the milliseconds, which is before 1000, right? So now the previous time is 1000, and it will repeat the if again. So it's still repeating the if in here even after it's more than delay time. So after that, because the milliseconds is 1000 and the previous time is now the same as the milliseconds, which is 1000, so now we have 1000 minus 1000 equals 0. And because the milliseconds is now 0, it will repeat again the if code. So from 1 again until more than the delay time, which is 1000, print, and then 1000 minus 1000 again, and then repeat again, like that. Okay, now I'd like to show a little bit of the demonstration. Here we play. So we wait first, and then there's a Wi-Fi, and as you can see, now it's trying to connect to the Wi-Fi first, as I've said before. After it's connecting to the Wi-Fi, later it will show that it's going to print the temperature that it's receiving. Okay, maybe because the internet here is kind of a little bit laggy, so for connecting to the Wi-Fi, it's going to take a long time. So I'm just going to show that if it's already detecting this temperature, it will show the information here in this part below, and then it will also show in the I/O, because after receiving the data or the data in the DHT22 sensor, it will send the data or the data to the weather station dashboard here in the I/O. Like here example I tried before, so I received minus 1.8 Celsius and 92% on the humidity, and then after detecting it on the DHT22, sorry, it will send the data to the I/O. Okay, maybe that's all. Thank you. Assalamualaikum warahmatullahi wabarakatuh.